Section 1.7. We are going to work in this section on perimeter and area. And before we do that, I'd like you to try these 3 questions. Again, these are things that are going to be reviewing some things that we have already worked on in chapter 1. This is our last lesson in chapter 1, but let's try these. I'd like you to try these 3 questions, see if you can get the correct answers and the correct setup work, and then we'll go over the answers. If you did your work correctly, the first question you should have noticed that it says BD bisects the angle. So it cuts it into 2 equal pieces. So that means you set the 2 expressions equal to each other and solve for x. Once you do that, you plug the value of x back into one of the expressions, which ended up to be 59-degree angle for each one. Add them together, 118. The second question, notice that the word regular. That means that all the sides are the same and all the angles are the same. So we set the 2 sides equal to each other. This one becomes more complicated as you solve, and you end up with x squared equals 16, which when you take the square root just gives you plus or minus 4. So x equals 4. And the third one is kind of tricky. The measure of one angle is 7 times the measure of its complement. Well, that means the 2 angles add up to 90 degrees. And if one angle is x, the other angle is 7 times the measure of x. So now you take 7x plus x and set it equal to 90. You get some decimal answers. That's okay. Not all values are going to work out to be nice numbers. You're going to get decimals and fractions at times. So in this section particularly, we're going to work on perimeter and area, circumference, which is really just the perimeter, of rectangles, squares, and circles. And we're also going to use information to find any missing information. Now this should be fairly familiar for you, so I probably will skip around a little bit and then you can just check back on the notes for any additional examples that you might want to review. So first of all, let's just get some basic terminology down. The perimeter is the total distance around a figure, okay? That's not anything new. We always label with the appropriate unit measure, like yards, meters, miles, feet, etc. If we don't have one, it's units. And just like when we were finding the length of one segment, we were using units. Well, now we're just adding up the 3 segments in this triangle to get the perimeter. Area, on the other hand, is the number of non-overlapping squares of a given side that will exactly cover the interior of the closed figure. So if you look at, these are the squares, okay, that are on the interior of the figure, and we want to know how many are inside there. Well, if it's a rectangle and it's drawn on a grid, it's super easy. But we have other ways to find that, and you've used these formulas before. Area, on the other hand, is always labeled with units squared, whatever it is. So here are 2 formulas here are 2 shapes, rectangles and squares, that you are very familiar with. And you are familiar with the formulas, I'm sure, as well. So perimeter, we add up all the sides. So if one side is the height and one side is the base, then we take the height plus the base plus the height plus the base. Or you have 2 heights, so 2 times h plus 2 times b. And the area is just the base times the height. Remember, the height always has to be perpendicular to the base. In a square, since all sides are the same, then we just add up all the sides, s plus s plus s plus x with s, which gives us the perimeter equals 4 times s. And for area, it is like base times height still, so side times side, which is side squared. So these formulas probably are pretty familiar to you. I don't think you will even have to memorize because you probably already do have them memorized. So find the area and perimeter of the given figures. Again, probably done this for a long time. But the area is going to be the base times the height, which is simply 108 feet squared. The perimeter, you're going to take the base, which is 12, multiply it by 2, and then the height times 2, and you add those together and you get 42 feet. Again, notice feet versus feet squared. The square, the area, equals 30 times 30, or 30 squared, which is 900 inches squared. And the perimeter is just 4 times the side length. So you get 120 inches. Very easy. So let's do some quick triangle work. Again, the perimeter, we're going to add up all the sides. And it's kind of awkward maybe to put this letter T on here, okay, because it's not always the same value, but it's the sum of all the sides. And the area is equal to 1/2 the base times the height. Again, familiar formulas. But remember that the height always has to be perpendicular to its base. And so sometimes the height is actually drawn on the outside. So be careful and be aware of that. So let's try a couple examples. It says find the area and perimeter of the given figures. Well, if we're finding the area is 1/2 the base times the height. Well, I can see that the base of my triangle is this piece right here. That is my base. Well, I don't know that right now. That is my base, and this is my height. My height is drawn outside. So I'm going to have to find the base. I already have the height, but I'm going to have to find the base. Well, I know that the whole side from here to here is 10. And if this much of it is 3, then the base has to be 7. So now I have 1/2 times 7 times the height of 4. So my area is equal to 14 miles squared. Well, now let's work on the perimeter. So our perimeter is equal to, one of the sides is 7. The other side, well, wait. We don't have this side right here. We need that. Well, notice that this forms, this 3, 4, and that side form a right triangle. So we can use the Pythagorean theorem to find S. So we can take 3 squared plus 4 squared, and that is going to equal our C squared. So 25 is equal to C squared, so C is equal to 5. And you know what? I'm guessing many of you would already know that this is that side that we actually wrote in is actually 5. So now we know 7 plus 5, but we also need to find this side right here. We'll call it X. Well, again, it's part of a larger right triangle. And if I highlight it here, maybe I won't use, yeah. Okay, so if I highlight this is also a right triangle. So now I can also use the Pythagorean theorem that 10 squared plus 4 squared is equal to C squared. So 116 is equal to C squared, and C is the square root of 116, which then if we round, C is approximately 10.8. So now we're going to add in that 10.8 right there. So now we can add up our perimeter, and our perimeter then is 22.8 miles. The second example on here I'm going to skip, but I'll go ahead and work it out when I post the notes. I think that's a pretty basic problem. I think you can handle that one. So, how about this one? Find the area and perimeter of the figure. Well, we have this graph, we have these vertices. Well, in order for us to find the area, we have to take the base times the height. Well, I can find this ordered pair. That ordered pair is 1, 2, 3, 4, 5, 1, 2, so this is 5, negative 2. So what is this length, this distance right here? What is that? Well, you can use the distance formula, or you can use the ruler postulate with just the x values. And what is the distance between 3 and 5? Well, that is going to be 1, 2, 3, 4, 5, 6. That looks like it is, I must have counted wrong. 1, 2, 3, 4, 5, 5, negative 2. No, that's right. Okay. Oh, because I'm doing the y values. Huh. Okay, so that is actually the length of the y values. So we have negative 4 minus a negative 2, which gives us plus 2. which gives us 6 units long. So this is 6 for this value. So this is 6, that is our height, and our base is the length of this right here. Again, we could count, pretty obvious, or we can get this ordered pair right here. And that ordered pair, 1, 2, 3, 4, 5, 6, is -6, -2. So again, I guess we would need this ordered pair above, which is -6, 4. No, we wouldn't need that, actually. We just need this. So we can take the difference in the x's here using the ruler postulate, which gives us 11. So our area is equal to 66 units squared. And the perimeter, again, pretty simple. Our perimeter is just, since we already found this is 11, we take 11 times 2 plus 2 times 6. So we get 121 plus 11 times 2 is 22. I wasn't squaring that. So 22 plus 18 gives us 48 units. So let's do some more challenging problems, because these are the ones that usually students have struggles with setting them up and solving because you're working backwards. I'm going to do 2 of these, and I'm going to have you try 2 on your own and maybe check the notes. So let's look at number 2. It says the perimeter of a rectangle is 28.8 centimeters. The length of the rectangle is twice as long as its width. Find the length and width. So a lot of times it's easiest to start out with the picture. Okay, so we know the perimeter is equal to 28.8. We also know the length of the rectangle, or the base, if you want to call it that, is twice as long as its width. So if your width is W, then your length is twice the width, or 2W. So now we can take our formula for perimeter. Perimeter equals 2 times the length plus 2 times the width, length and width, base and height. You can change those back and forth. So now we're going to put in the value that we have for the perimeter, and 2 times the length, which is 2W, plus 2 times the width, which is 2W, 2 times width, and that is going to give us the 2 times 2 is 4W, plus 2 more gives us 6W is equal to 28.8. Now we just divide by 6 on each side, and we get our width then is equal to 4.8 centimeters. And the length then is twice that, so that is going to be 9.6 centimeters. So that's how we work backwards. Let's try number 3. I'll work through that one with you, and then again, I'll have you try to work through the second 2 examples, numbers 1 and 4, on your own, and you can check the notes for to see if you got it right. So this one says the perimeter of a rectangle is 100 inches with a base length of 40. What is the area? So now we're going to have to find the other value and then plug it back in. So one of the things that makes these challenging is make sure you're answering the questions that they ask. So we know, again, our formula for perimeter is equal to, this in general, is equal to 2 times the base plus 2 times the height. We already know that the perimeter is 100, and we know the base is 40. So 2 times 40 plus 2h is equal to 100. Well, 40 times 2, that's 80. So when I subtract 80 from each side, I get 20 is equal to 2h. So h is equal to 10. So now I know my base and height. And again, it may have been helpful to draw a picture over here that we would have the perimeter equals 100, and we already know the base is 40, and we're trying to find the height, which we just found is 10. So now the area is what we're being asked to find, which is the base times the height. Or our area is equal to 400 inches squared. All right, so let's move on to circles. Here's some terminology for circles. We have radius, r, is the distance from the center of the circle to any point on the circle. The diameter is the length of the line through the center of the circle with endpoints on the same circle. So these are the formal definitions. I know you already know what they are, but the radius is the distance from the center to any point on the circle. So you could draw in an infinite number of radii. And all of those radii together form the circle. So here's one point on the circle, here's another, and then they continue going. Diameter is the length of the line through the center with endpoints on the same circle. So here's our endpoints right here, and it goes through the center. So that's important as well. The circumference is really just the perimeter. It's the total distance around a circle, and it is the perimeter for circles. So you can actually use for circumference two different formulas, because you can either take your diameter times pi, or if you know your radius, you can take 2 times your radius right here, which will give you your diameter, times pi. Either one is fine. I tend to use whichever one makes more sense to use in the problem. And then the area is simply pi r squared. Now sometimes people get those mixed up between 2 pi r and pi r squared, and that's why I tend to lean more towards the pi times diameter. Now, if you look down here, there is a link. If you want to copy and paste this link, it's kind of cool. It talks about circles, and it kind of shows you visually about these formulas. So let's do a couple examples. Let's find the area and circumference of the given circles to the nearest tenth. This is probably what you're very familiar doing, okay? So if we find the area, we know the area is pi times our radius squared, so 32 squared. So if we just multiply that on our calculator, we get 3,216.991. When we're rounding to the nearest tenth, this actually, we look at this number right here, and since it's 9 or 5 or more, we have to round up. So this actually rounds to the nearest tenth to be 3,217 centimeters squared. So be careful, make sure you know how to round correctly. For circumference, the circumference is pi times diameter, or in this case, it might be easier to use the 2 times the pi times the radius, which is approximately 201.6 centimeters. Now, if you're looking for your pi button on your graphing calculator, you're going to have to use the second button with the pi button, which is right under the clear. So look for that. I'll let you do the second example. Again, I think you can handle this, but I will work it out in the notes. So let's go on to talking about what do we do if it says to find the exact. When it says to find the exact right here, we leave pi in our answer. We don't multiply it by pi. We do everything else but that. So if we are finding the exact area and circumference of the circle, this is how it's different. So the area is pi times our radius squared. Well, 15 squared is 225. So the exact answer is 225 pi. And then again, we have yards squared. Now, it doesn't seem like it's more exact, but it is, because you're not rounding any of your answer. All of the digits and decimals places for pi are in your answer still. For circumference, we can do 2 times pi times our radius. So for circumference, we get 30 pi yards. Pi, we kind of treat it like a variable, and that's why I moved the number to the left of pi. It's just the more appropriate way to write it. So here's an example, an application problem, where it says a countertop company measures the surface of a sink countertop to be 7 feet long and 2 feet wide. So this is 7 feet and this is 2 feet. The countertop will have 2 sinks cut out of the countertop as shown below. How much area will the countertop have? So what we're looking for is how much area would be this part in here. So what we're going to have to do for this problem is we're going to have to find the area of the rectangle, and we're going to have to subtract the area of the two circles. So the area of the rectangle, that's pretty easy. That is just 7 times 2, which is 14 feet. So now let's work on the circle. And you might be saying, well, how do we find that? Because we don't have a radius or diameter. But again, notice how this is touching on each side. So you do actually have this diameter because it's the same as this side right here, or the height. So your diameter is 2 feet. So the area of the circle, I have 2 of them, but I'm going to take pi times my radius squared, which my radius is then just 1 squared. Well, 1 squared is 1, so now I really just I'm subtracting pi times 1, which is 1 pi, times 2, so I'm subtracting 2 pi. So I'm not even going to get a decimal answer for 2 pi. I'm literally just going to leave that there, and I'm going to take 14 minus 2 pi on my calculator, and that gives me approximately 7.72 feet squared. Now it said the nearest tenth. Normally if I don't notice that, I go to the nearest hundredth, but it says 7.7 then feet squared. And let's work on a couple of these circle problems where I work backwards. I'll try at least one with you, and then you can always look at the rest of the notes for more examples. It says find the exact area of a circle with a diameter of 16 inches. I think you can handle that one. So let's look at this one. The circumference of a circle is exactly 24 pi feet. What is its diameter? Well, we know that the circumference formula is pi times the diameter, or 2 pi r. So in this case, since most of you, I guess, are probably going to want to use, I would probably use the other formula, but we'll go ahead and use this because I think from past experience, most students prefer this formula for circumference. So now I plug in my circumference for this. So 24 pi is equal to 2 pi r. So what I'm going to do here is I'm going to divide, like most of you would do, by 2, but I'm going to actually divide by 2 and pi at the same time. So the pi's cancel out, and the 2's on this side. Pi's cancel out, and so what I get after I cancel is 12 pi is equal to my not 12 pi. 12 is equal to my radius. I already canceled my pi's. So now my diameter is 2 times 12, or 24 feet. Number 3, the area of the circle is 169 pi square millimeters. What is its circumference? So area is equal to pi r squared. It tells me the area is 169 pi, and that is equal to pi r squared. So again, I'm going to divide. I'm trying to find the radius. Divide by pi, that cancels out. But now I'm left with radius squared equals 169. So again, to solve these, I'm taking the square root of each side. Squares and square roots are the opposite operations, so they cancel each other out. So I get my radius then is plus or minus 13, but I can't have a negative radius, so my radius equals 13. Now, you might think, oh, I'm done. But remember, this question asks you what is the circumference. So now my circumference equals 2 pi times 13. And so this is equal to 26 pi millimeters. It didn't say to round, so you can actually just leave your answer like that. You can actually leave your answer exact if it doesn't tell you one way or the other. If you want, you could certainly multiply by pi and round. All right, that is the end of lesson 1.7, and